Hello, how are you all? The GATE 2025 aspirants. Today is day 2. Yesterday we started the control systems. Have you gone through the day 1 video? Today is day 2. Today we start from the topic block diagram representation, signal flow graph. We call it as signal flow graphs. The definition: it is the graphical representation of the mathematical relation between variables of a system described in the terms of set of linear algebraic equations in cause effect form. We have to highlight and note that, underline that, linear algebraic equations in cause effect form. First, transfer function is applicable only linear. That's one point. Second point, algebraic equation is must not an integer and differentiator. Okay. Because the integrator and differentiator has not shown in the graph. So third one is it must and should be in cause and effect form. Here is the representation of block diagram representation. Have you seen that there is the block adder and subtractor? Next one is block. Next one is first block is 1 by r, second block is 1 by, in between there is the current, and the output is v0. From that we can take feedback path through the input adder and subtractor. The output, we see that the takeoff point or breaking point, we call it as. Next one is signal flow graph. We saw there is signal flow graph. Once see that regarding the block diagram representation of that circuit, we draw the signal flow graph. See, block diagram representation is 3 standard topologies. We have 3 standard topologies. What is meant by topologies? It describes the interconnection. First one is series or cascade, second one is parallel or feed forward, third one is closed loop or feedback or canonical. First one we saw that series or cascade. We see the representation: R of S input, C of S output, in between R2. We can what is transfer function? Transfer function is output Laplace transform of output by Laplace transform of input with 0 initial conditions. We can see here Laplace of output is C of S, input is R of S, C of S by R of S. Here we use series connection. That's why we multiply the blocks G1 of S into G2 of S. This is series connection. Coming to parallel or feed forward, we saw that the blocks are connected in parallel. That's why we take that C of S by R of S equal to G1 of S plus G2 of S. That's it. Parallel. We see the third one, closed loop or closed loop or feedback or canonical. We see that here is the representation of the closed loop. It look like this block diagram is look like say closed loop path. Say here is the adder or subtract, that is called, which I highlighted, I wrote with the blue color pen. This is the error detector, this is the plan, this is the sensor. First of all, we see that G of S equal to C of S by E of S equal to forward path. We see that one in the block diagram. H of S equal to B of S by C of S is feedback path transfer function. Next, C of S by R of S equal to G of S by 1 plus or minus G of S plus H into H of S is closed loop transfer function. We see and observe carefully each and every point. E of S by R of S equal to 1 by 1 plus or minus G of S into H of S equal to error transfer function. That's the three topologies what we have. Next one is Mason's formula. We saw that Mason's formula, transfer function equal to summation k equal to 1 to power n pk delta k by delta, where k equal to integers 1 2 3 and so on n equal to, here is n is equal to number of forward paths, and pk equal to gain of kth forward paths. Delta, here is the delta equal to determination of signal flow graphs equal to 1 minus sum of all individual loop gains plus sum of product of two non-touching loop gains. That's it. Delta k equal to determinant of kth forward path equal to 1 minus sum of all individual loop gains that are non-touching to kth forward path plus sum of product of two non-touching loops gains that one not touching the kth forward path. That is representation in the Mason's formula. We see there is a terminologies which we have to node. First one is node, it is represents a variable, number of nodes equal to number of variables. Second one is input node, the node that has only outgoing branches, that is called input node. What's output node? The node that has only incoming incoming branches, that's output node. Forward path, coming to forward path, fourth one, the path that connects input node with output node such that no need is repeated, that is forward path. Loop, fifth one is loop, it is a closed path that starts and ends at the same node such that no node is repeated, that is loop. Next one is non-touching loops. Coming to the non-touching loops, two or more number of loops are said to be non-touching if they do not have any common node. This is called non-touching loops. Coming to you, by using this Mason's formula, we have to solve the problems. Some problems which are given in the textbooks or some YouTube, whatever reference take. That's all for today class. See you in next class. Thank you.